You are welcome to this channel, viewers and students, A-Startutors Academy. Here we treat various topics in chemistry and other sciences. We treat questions, past questions on exams for students to be well prepared for the exams ahead of them, and also for any areas where students may be having challenges, any topics in which they may be having challenges. For inquiries, you can contact me through the WhatsApp numbers displayed on the screen. Today we shall be looking at various calculations, problems, and see how we solve them. Question number 1. What volume of oxygen at STP is required for the complete combustion of 5.6 dm cube of methane? This is a stoichiometric question, and we are going to see how to approach this question and solve with ease. If you look at the question, we are finding the volume of oxygen that 5.6 dm cube of methane will require for complete combustion. STP is standard temperature and pressure. How do we approach this question? The first thing I would like us to do, or that you ought to do, is identify the two substances that are related together, and these are methane and oxygen. We want to find the volume of oxygen that this volume of methane will require for combustion. So the first thing, identify the substances that are compared together, that are related together. And number 2, go to the equation and try to define the mole ratio of the two substances related together. So the mole ratio is going to be 1:2. That is 1 mole. For every 1 mole of methane, 2 moles of oxygen will be required. So we start from there. So by stating the mole ratio, so we have 1 mole of methane, 1 mole of methane requiring 2 moles of oxygen for complete combustion. Then the next thing that you do, since we are finding the volumes of oxygen required by 5.6 dm cube of methane, we are going to relate them volume to each other. So how do we convert the mole to volume? Don't forget the volume at STP. And let me quickly chip this one in. According to Avogadro, the molar volume of any gas at STP, standard temperature and pressure, is 22.4 dm cube. That is, 1 mole of a gas will occupy that specified volume, according to Avogadro. So we are going to convert this to volume. We convert this to volume since we are determining volume of one from the volume, required by the volume of the other gas. So if you want to convert to volume, using volume to volume, you have to multiply the 1 by 22.4 dm cube at STP of methane, and this will be 2 times 22.4 dm cube of oxygen. We are converting to volume. So we have now 22.4 dm cube, which is the volume of methane. 1 mole of methane. It will be requiring 44.8 dm cube of oxygen, according to the equation. Then what do you do next? You now bring this one, bring it down to 1 dm cube. So 1 dm cube of methane will require 44.8 divided by 22.4 dm cube of oxygen for combustion, and that will give us 1 dm cube equals 1 dm cube of methane. When you divide this volume by each other correctly, we are going to have 2. So 1 dm cube of methane will require 2 dm cube of oxygen at STP. Then finally, we go to the required volume. The required volume in question, the volume put into reaction, is 5.6. So 5.6 dm cube of methane will require 2 times 5 dm cube. That will be 2 times That will be 2 times 22.4. 2 times 5.6. Yeah, 2 times 5.6 dm cube of oxygen. So this will give us 11.2 dm cube of oxygen at STP. So this is the volume of oxygen that 5.6 dm cube of methane will be requiring for complete combustion. Question number 2. So the answer is C. Question number 2. During the electrolysis of acidified water using platinum electrode, the ratio of gases produced at the cathode and anode respectively is what? Let me expatiate on this question. This is a question on electrolysis. Acidified water is water that is water that is mixed with H2SO4. That is, when you add some drops of H2SO4 acid to the still water, it becomes acidified. That is how to prepare acidified water. And the electrolysis of this acidified water using platinum electrode will produce hydrogen and oxygen. Now, during the electrolysis at the cathode, the ions that will migrate to the cathode are hydrogen ions. So when the hydrogen ions gets to the cathode, it's going to gain 1 mole of hydrogen ion will gain 1 mole of electron each to form hydrogen atom. As we all know, hydrogen is a dimolecular gas. So we are going to have 2 of these combining, and that will be 2 electrons to be required altogether, will be gained altogether. Then we have a molecule of hydrogen gas. That is the equation that occurs at the cathode. The equation that occurs at the cathode during the electrolysis. And the next thing is to determine the reaction that will occur at the anodes, because this is a redox reaction. At the anodes, anode is the positive electrode where negative ions migrate to and become oxidized. 2 negative ions in the electrolyte are as follows: OH minus and SO42 minus. OH minus from the water, SO42 minus from the acid in the water. But according to the relative positions of these ions in the electrochemical series, you have to be familiar with the factors that determine the preferential discharge of ions during electrolysis. Now, these 2 ions will migrate, but according to the relative positions of the 2 ions, OH minus is less electronegative, so it has higher tendency to lose electron faster than the SO42 minus. That means OH minus will be preferentially discharged. Each OH minus, on getting to the electrode, will release 1 mole of electron to become OH minus. But as we all know that this does not exist as a molecule. So for us to have a molecular gas as products, we need to combine 4 of these. So when you have 4 of OH minus coming together, losing 4 moles of electron altogether will form 2 molecules of water and 1 molecule of oxygen, 1 mole of oxygen. Now, it means at the anode, when OH minus is discharged preferentially, 1 mole of oxygen gas will produce. Now, for us to combine the 2 equations, the 2 half equations, we need to make sure that the number of electrons are equal. We equalize the number of electrons in both equations. So I will have to multiply this by 2. On multiplying by 2, then we have this. We are going to have 4 moles of hydrogen ion gaining 4 moles of electrons to give 2 moles of hydrogen gas. 2 moles of hydrogen gas. Then bring this also down. We have 4 moles of hydroxide ion losing 4 moles of electrons to form 2 molecules of water and 1 mole of oxygen gas. So we have 1 mole of oxygen gas. Now the reason why we have to do this is because during electrolysis, the number of moles of electron lost will also be gained. So if 4 moles of electrons were lost at the anode, it goes round through the external circuit, and the same number of 4 moles of electron will enter. So the number of electrons must be equal, so that when we combine the 12 equations, we can have those electrons deleted. And therefore, it means, if you look at the equation, it means in the electrolysis of the acidified water, we are going to have 2 moles of hydrogen. So the volume ratio or the mole ratio of the hydrogen to oxygen is going to be 2:1. That is 2 moles of hydrogen and 1 mole of oxygen. So the correct answer is C. Question number 3. In the equilibrium reaction below, this is a question on equilibrium, chemical equilibrium. In the equilibrium reaction below, this is another process. Which conditions favors the forward reaction? Now, if you look at this equation, you can see that there is loss of heat. The forward reaction, which leads to loss of heat, evolution of heat, is exothermic. Forward reaction is exothermic. Forward reaction is exothermic. And on the other one, backward reaction is endothermic. These are the two processes. Now, which condition favors the forward reactions among these conditions? If you want to consider the effect of temperature change, generally, when we increase temperature of an equilibrium reaction, the endothermic reaction will be favored. But when we lower the temperature, exothermic will be favored. So that means endothermic reaction is favored at high temperature, while exothermic reaction is favored at lower temperature. Meaning that if you are considering the forward reaction, which is exothermic, what we should favor that, if that is here, it should be decrease in temperature. Now that we don't have temperature here, we don't have that option, then we have to consider another factor. Another factor that affects the position of equilibrium is change in pressure. Now, if you consider the effect of change in pressure on this reaction, pressure change affects equilibrium position in such that when pressure is increased, equilibrium position will shift to the side where the total volume or moles of gases is lower. At higher pressure, equilibrium will shift to the side where the total volumes or total number of moles of gas is less. So if you look at this, the total volume or moles of the gaseous reactant is 4. 1 plus 4, making 4 moles or 4 volumes. Here on the product side, we have 2 moles. Now, and we are concerned about forward reaction, that is formation of ammonia. So the condition that will favor the formation of ammonia, according to this equation, is when the pressure is decreased. Increase in pressure. That's increase in pressure. When the pressure is increased, equilibrium position will shift to the side where the total number of moles of the gases or volume of the gases is lower. So at higher pressure, equilibrium will favor the side where we have the lower volume or lower moles of gases. So the correct answer here is D. Increase in pressure will favor the forward reaction. So the option is D. Question number 4. Question number 4. A hydrocarbon contains 85.7% carbon by mass. Determine the empirical formula. Empirical formula is also known as the simplest formula of a compound. Now, being an hydrocarbon contains carbon and hydrogen. The percentage of carbon here is 85.7%, and that means the percentage of hydrogen will be 100 because the total must be 100. So 100 minus 85.7, that gives us 14.3%. Then the next thing is to find the empirical formula. We determine the empirical formula. I'm going to make it in a tabular form for it to be clearer. So draw the table just to arrange the work. We have carbon, put this here. These are the elements. The first thing that we state here, we are going to state here is the percentage by mass given or calculated. We have 85.7 and we have 14.3. The next thing you are going to state is the relative atomic mass of the element. Carbon is 12, hydrogen is 1. The next thing that you do is to divide the percentage by mass by the relative atomic mass of the element. So we have 85.7 divided by 12, then 14.3 divided by 1, and this is what we call the mole. So what you are calculating there is the mole. This will give us 7.14 to 2 decimal places, 14.3. Then the next thing that we do is to divide by the smaller one, divide the 2 by the smaller mole. The smaller mole is 7.14. So 7.14 in order to have the ratio in nearest whole number. So 7.14 divided by 7.14, then 14.3 divided by 7.14. This will give us ratio 1 to 2. Ratio 1 to 2. That means the empirical formula of the hydrocarbon is going to be C1H2, which is CH2. That's the answer. So the correct answer is B. The correct answer is B. Question number 5. A gas occupies 300 cm cube at 27 degrees Celsius. Calculate its volume at 127 degrees Celsius if pressure remains constant. If you look at this question, this is a question on gas laws. And precisely, specifically, this is a Charles law question. Question is on Charles law. According to Charles law, the volume of a fixed mass of gas is directly proportional to the absolute temperature provided that pressure remains constant. Or the volume of a fixed mass of gas is directly proportional to the temperature in Kelvin provided that pressure remains constant. So volume is directly proportional to the temperature in Kelvin while pressure remains constant. And for the benefit of calculation, this is what we use. This is what we use. So the V1 and the T1 are the initial values, while the V2 and T2 are the final values. Now, whenever you are solving question on gas law that involve temperature, that you have to involve temperature in your calculation, it is very important that the temperature should be converted from degrees Celsius to Kelvin temperature. You convert the Celsius temperature given to Kelvin temperature. So what do? You had a fact, a 273. That's what you had. Now the V1 is 300 here, 300 cm cube. The T1, that's the temperature at which the volume is 300. We are given 27 degrees Celsius. To convert it to Kelvin, you add 273. And that gives us 300 Kelvin. That's the Kelvin temperature by conversion. The volume 2 is what we are looking for. We are looking for this, the Newt volume, and the temperature at which we are looking for the volume is 127 degrees Celsius. So the same way, add 273 to convert it to Kelvin, and this will give you 400 Kelvin. Then you can now apply this formula. Apply this formula. So we have V1 is 300, and the T1 is 302. The V2 is what we are looking for. The T2 is 400. And if you look at this, this is 1. So this is 1 equals V2 over 400. When you cross multiply, you have 1 times 400 equals V2. 1 times 400 is equal to V2. And that means the V2 is 400 centimeter cube. That is the volume that the gas will occupy when the temperature is increased from 27 degrees Celsius to 127 degrees Celsius. Don't forget, Charles law established that the volume will directly be proportional to the absolute temperature. That means if the temperature is increased, the volume of the gas will also increase proportionally, and vice versa. So these are the 5 questions we have been able to solve in this video and the solution. Kindly subscribe to the channel A-Startutors Academy. For inquiries, you can contact me on this WhatsApp number. And if you have comment, kindly drop your comment in the comment section. Any topic that you want us to quickly address in the next video, kindly drop your comments, and if it is very urgent, please put your call or message across to me. Thank you. Watch out for the next video. Thank you.